Yeah, thank you.
Yeah.
Thank you very much. Okay. So this working group is IPv6 and 5G. Okay. So we cannot separate both of it. Okay. Today, 5G works together. Without IPv6, 5G to move forward is very difficult. Okay. So it's interwoven itself. Okay. So what we are talking about today, as you well discussed this morning, I think morning if you see Dr. Hafiz tried to share with you the challenges in BGP security. Remember, of course, having network, great, all network, but talking about security, this is the biggest challenge. All right. Today we have very good network, but there are a lot of security issues that we are try to address. So one of the things, like what I said, mentioned to you, now we are moving towards 5G. Of course, there's a lot of discussion is already going on 6G, right? And people are talking about 7G and so on. So that's near to us is still 5G, which is start being implemented. So there's a lot of advantages of going to 5G. Obviously, many of you knows what is 5G all about, fifth generation. So let me quickly share with you what is 5G all about for those have not much of knowledge on 5G. So what you can see this in terms of 5G, it is part of the ITR IMT 2020. So the 5G that we have, like 5G is divided to two portions. One you call sub-6. Sub-6 means performance-wise up to 1 gigabit per second. So that was the initial. Actually, there's 4G plus. We call it 4G plus. All right. And 5G, we are talking about 5G, we are talking about 5G core. Really 5G core. So what 5G core can do, all right? So technically speaking, this is all technical, but comes to implementation, it's a different thing. What 5G brings to you on the table. And IPv6 has to go with, without IPv6, 5G is not to be implemented. It's not easy to be implemented because currently we are running on IP addressing. So IPv6 definitely required for 5G implementation. So the fifth generation, what we are talking about, whenever we talk about fifth generation, we talk about 4Ws. Do you know what 4Ws are? Any idea? When we talk about 5G, we always talk about 4W. Any idea? What do you think? You know 3W. What is 3W? World Wide Web. So when you talk about 5G mean another W in front. Wireless, yeah. Wireless World Wide Web. So whenever you talk about 5G, we are talking about wireless, right? It's all vertical, right? Comes talk about vertical. So you can't run away. So today is the buzzword. 5G is the buzzword now everywhere, So a lot of things have been discussed, and we are moving towards slicing technology. We are talking about SDN. So a lot of big thing. So when it comes to 5G, now the traditional network knowledge no longer applicable. You understand now? No longer applicable. Of course, you already learn about basic traditional knowledge. Talk about routers, firewalls. So you know all these things. Comes to 5G, it exists, but it's all softwareized. The name still exists, but all softwareized. So we are now talking about virtualization, softwareization, and that's what comes to talk about. So what 5G offers? 5G is actually offers to you data rate. Okay, actually, according to the spec, you can go up to 20 gigabit per second. The speed. No, when we talk about today, everything we talk about speed. All right, 5G, today we want high speed. So that's why 1G, 2G, 3G, and 4G and 5G. So some countries 3G no more already, deprecated. Okay, some still running in 2.5. So the edge technology is still there, but most of them already moved to 5G. So what it promise quite a number of things, 20 gigabit per second. Technically, it's technically we're talking about 20 gigabit per second. But in the reality, it's different. But what the other one, the one in the smaller one, that is what we have achieved so far is 10 gigabit per second we're talking about, right? We are talking about, 20, yeah, there's talking about 1 gigabit per second in terms of peak data rate, sub-6. So in terms of data experience, so you can see 10 and 100. I mean, if really 5G core implemented, most of the networks that today are running on sub-6. It means the RAN part is 5G, the IT part, the IP core part is still, people is 4G plus or 4G, all right? So EPC core, we call it EPC, all right? So when you go to 5G core, now many countries still not gone to that level yet. So even in Malaysia, we have already got 5G, but we only talk about sub-6 5G. You mean maximum you can go 1 gigabit per second, not 20. 20 is really 5G core. If you implement 5G core, and 5G core in most of the world implementation is still on the trial because it's involved quite a number of things. So that's one. Then in terms of data experience, you can get up to 100 megabit per second. Efficiency, with 4G plus or talking about 5G sub-6, you can go up to 1 times. Here is 3 times spectrum efficiency. So when it comes to 5G, we are talking about the radio part as well as the IP part. So the radio part already 5G. The IP part, that's why people still use EPC core, which is 4G enhanced, 4G plus. So mobility, how much you can go, like 350 up to 500 5G. And latency, and this is very important today. When we talk about latency in 5G, what we want to achieve is 1 millisecond. But can we achieve now? I don't think so, right? So relatively, we can go 10 milli. Okay, we are talking about 10 millisecond. That is very good enough, 10 millisecond. So a lot of people are not talking about 5G. We are talking about driverless car. Tesla is talking about this. I think in China, there's a lot of implementation happening. I saw one video in China when they implement driverless car. The car was driving, the command center cannot control it. There was one video and there was a lot of tests going on. So there's a lot of challenges. 1 millisecond we want to achieve is quite very good, so that human to computer reaction will be 1 millisecond enough. And like if you're driving a car with the driver, without a driver, suddenly you want to ask to brake. Let's see, the AI doesn't work within the car. You can hit the accident. And Tesla have failed in some other things. So that's why the driverless car is still, it's not in commercialized fully, still in test stages. Of course, this is what we want to achieve. Of course, in China, there's a lot of case study of 5G. Now they're using in, 40 dangerous, dirty jobs, So we're using 5G for that, all right, because of the efficiency. Then we are talking about connecting, can connect more devices, energy efficiency. Because nowadays with the EVs, right, with the EV technology, with the battery technology is going better, a lot of things. So 5G brings a lot of advantages in terms of what you can achieve. So in 5G, there's 3 angles that we talk about. EMBB, which is enhanced mobile broadband. And we talk about the other corner is, we talk about UL, ultra reliable low latency communications. And we are talking about massive machine type communication. I think EMBB in terms of practicality, okay. In mobile phone, you got 5G. What do you do with it? What is the maximum application you can run? What is the best application or require high capacity? What do you think? What is the highest application that require a lot of bandwidth? Video streaming, Netflix. Nowadays we are no longer traditional, right? Everything now, either like in Malaysia we have, we used to have a satellite Astro. Now Astro is losing business. Now everybody is using internet to watch movies, Netflix. So EMBB for me, it's not relevant too much to the user. You know why? If you have, let's see, you have 10 gigabits per second on your mobile, what's the use? Is there any serve any use or not? It doesn't. For now, no logic, because you don't require so much. Standard, how much you're using now? Like even 200 megabit per second, is good enough, correct or not? Huh? So nowadays you can run Netflix with your mobile phone, so not relevant. So the most important part is URLLCC, we were massive communication with low latency. So today you can see, later there was a gentleman here was talking about from Nokia. Now we are moving towards 5G networks where we need latency very low, because critical application like banking applications, they require the more high latency mean you're talking about security. Not only fast response, we are talking about security. So security is the biggest challenge. The more higher latency you have, it means less secure your communication. So that's why we want to achieve 1 millisecond, not only for fast response performance, but we are talking about security. So later we're going to talk about the security part. So the higher is the latency, more chances the attacker can attack, brute force attack. So that is the reason. So URLLCC and massive precision communication, these are the main application of 5G. All right, this is what we want to look at it. So this is the 4G model, which you are familiar with the 4G model. You have S1, S5, this IP core. I mean, I'm just forgiving for, this is the old model. And this is, they are now, when it comes to 5G, we are separating the user. So we are using data plane and control plane. This is where the SDN. So when it comes to the 5G, that's why I was mentioning today, everything is softwareized. The router no longer a physical router, it is a virtual router. So when you talk about virtual router, now we are splitting the old controllers to, one is control plane, the other one is user plane. So this is the technology when it comes to 5G. I mean, I'm not here to just teach you about 5G, but I'm here to talk about the 5G security challenges, all right? So this is all working on softwareization. The minute you go softwareize, let me tell you, security is in stake. Do you know now in the world, now every phone of you is connected to internet. I would say 95% of your phone already, there is a malware running on your phone, honestly speaking. Because the minute you connect to internet, that's where the attack takes place. So if you know now, a lot of top leaders nowadays, they use phones without internet connectivity. You've seen the BlackBerry issues earlier. So security is the biggest challenge now. So now all we are connected to internet, and we are running on 5G, all right? So the attacks going to be more. So these are the planes that we are going to talk about, how we are splitted. This is the basic knowledge I'm just to share. So we have AMF, SMF, which talk about a distributed plane, packet forwarding. It's all softwareized. So 5G means we are going for software plane. We have user plane, and we got user plane and control plane. So I don't want to talk more on to this, but the more my focus is, this is also, you see, slicing, network as a service. I think all of you are familiar with cloud computing, correct or not? So you got SaaS, PaaS, and infrastructure as a service, software as a service, right? So, and this is what is going on in 5G. Today, everything is, we are talking about cloud. We need to move from traditional to cloud to provide a service. To have an efficient service, bandwidth improve, we have to move to cloud. And cloud works very well with 5G, right? Cloud, edge computing, and so on. So that's what we are talking about. So you have all the standards. We are talking about 3GPP. Of course, now most of the IP part are reference to 3GPP. So people are talking about 5GPP. 5GPP is to the core, 5G core. When you talk about 5G core, the components are different, all right? So 5G core, and we got to talk about the Ethernet forwarding like 8.1 cm, this IEEE standard, and CPRI, Common Public Radio Interface. And we talk about front haul. So all these are technologies has been all softwareized. So everything is on the software base now. So I'm cutting short to that. So this is basically the whole scenario how 5G gonna work in 5G core. If you are familiar with 5G, there is current 5G, it's a 4G plus, which is 5G. But this is 5G core that actually going to change the landscape of 5G core. So you see customer unit, then RUs, radio unit, and distribution unit. So all these are softwareizing. Even your RAN, radio access network, people use MIMOs, multi-input, multi-output, and so on. So what we are trying to do, we are trying to improve the performance. So coming to security, I mean, that is just to give you a basic idea what 5G all about, 5G core. If you're 4G core, EPC core, it is 5G. So what is happening now, 5G? The minute you are already going into internet, software based, you actually increase security risk. Generally, the minute your device is connected to internet, you actually, risk is there. 5G mobile network are subject to increased security risk compared to 4G because everything is softwareized. And there's a lot of checkpoints that you need to make. And as attack impact, risk exposure, and easy exploitation of all increase. So moreover, increased network complexity makes detection more difficult. So security becoming more challenging when it comes to 5G, right? It's no longer, because everything softwareized, the endpoints, everything is softwareized. And when you're softwareized, it's easy to attack rather than traditional. It's traditional, that's why I was just mentioning. Nowadays, top leaders in the world, they don't use any more internet phone. They use only voice services because there's easy access to. So what happened? Therefore, the network operator security strategy needs to redesign. So all the knowledge that you have in 4G, 3G, has to be reworked up. Like some of you have knowledge in IPv4. IPv4 knowledge is applicable, but just having IPv4 knowledge is not applicable in IPv6 because the technique is different, IPv6. Some of you already exposed to IPv6, subnetting. The technique is different. The terminology is different and so on. So same goes to here. Here fully, we actually increase exposure, ease of, okay. So exploitation, increase security, all these things added up, okay, to increase security issues. Okay, so what is 5G security? This depends on who you ask. Okay, depends on who do you ask. Okay, as public perception, this perception public, and this is standard. Cloud edge computing, we got NFV, SDN, is intelligent AI-enabled security controls network. So coming to security, today people are talking about AI. No longer, the security no longer a manual security anymore. You need to go and manage your firewall yourself. Of course, there's IDS, IPS, which you are familiar with, but firewalls are AI-based firewalls. Today, AI becoming a very important role. So AI, everything is AI now. Now ChatGPT, one common. There's a lot of AI things are happening now. So the networks also using AI for managing. So this is the public opinion. Public opinion always good. Hey, very good. We're using edge computing near to the device, low latency. When it comes to security, we always talk about latency. All right, latency. If we wanted to reduce the latency, mean reduce the communication between the end device and to the processing device. So if you want to run driverless car, 1 millisecond. If you go to center and come back, you won't get 1 millisecond. So the 1 millisecond that we are talking about is edge computing. It's no longer to central command center and come back. So this is what we want to achieve. So as usual, the truth lies. So when it comes to standard, there's a lot of standards that talk about security, but also includes aspect of system secure and integration, security monitoring, incident response. So security is today a big challenge. Yes, we are moving to new directions, new technology, but as we move on, even IPv4 got a lot of problems. Introducing IPv6, there is, of course, It basically solved the problem, but it increased the opportunity exposure. Like we learn, when we start IPv4, we say IPsec is mandatory, correct or not? 1999 is mandatory, and we talk about SCND. Suddenly, as we implement, IPsec is not relevant. Not say relevant, it's become optional. Initially, the RFC said mandatory, but later part we have, when we move to IPv6 implementation over time, because we have this bootstrapping problem. Bootstrapping means, IPsec to work, you need to have IP address. So before even the IP comes in, there's a security attacks in the network. It's attacker there. How are you going to solve the problem? We cannot solve the problem. So these are the things when it comes to art. So always security is afterthought. We need to have the road first before you talk about fencing the road, correct or not? Like you have a highways, right? Like you have normal roads. Normal roads, what is that? No security, no fencing. When you talk about highways, because we are charging, we put everything. Of course, in Malaysia, in this country, we are paying. If you go to UK, you don't pay because there's been highways zero. You don't need to pay any tariff, right? So that is the scenario similar. So what are the challenges? 5G security, added complexity, security risk, and high degree of virtualization. Okay, these are the challenges. Cloud usage, cloud itself, software-defined network, the security points. Second, diverse technology ecosystem renders compliance to industry standard and best practices. Nowadays, new players are coming in. When come to 5G, no more Nokia, no more Cisco, right? Because they are not a dominant player anymore. New, when it's come to vendors. Once 5G opens up a lot of door for small players to come in. Kafka, so many of them, so many databases are coming in, new databases. You talk about new players are coming in. Okay, so traditional players no more already there. All new players are coming in. You can see more things happening. Drive customer expectation require more open and interconnect. So today we want open architecture. No more proprietary. Like last time, everything Cisco, or you talk about one. When we study, we all to device. Now we talk about non-device based, open. So anything need to work. So when come to 5G, everybody work to everyone. Like human being, we cannot group ourselves alone. We have to work with everyone. So that is what 5G talks about. You need to work with various vendors. Diversified service offering complicates assurance of continuous level of security. If one device, one player is okay. If you've got multiple devices, how do I assure the open standard? Standard is also argument. A lot of argument are going on the standards. Even 5G, a lot of arguments are going on the standards. Which standard do I want to follow? Europe? Japan? Japan wanted to have their own standard. Probably China propose another standard. So there's a lot of argument. So that's why we need to go for open. So coming 5G challenges are there because interconnectivity, with the devices. Then greater functionality, disaggregation through radio access network. Now you're talking about RAN. Radio access network is softwareized. When you're softwareized, the radio network is different altogether. You expose your network to more vulnerabilities. New and untested protocols. New protocols were introduced. Remember in the morning, Hafiz was sharing with you BGP-SEC. Correct or not? How many of you exposed to BGP-SEC? Not many. Even RPKI for that matter. Of course, there's a lot of argument going about RPKI. So now we need to secure. Security is the biggest challenge. So heavy use of common protocol, okay, low barriers of unexperienced vendors as well as attackers. Since there's new players are coming in, these new players, they're not experienced, You understand now? The more new players comes in, there's more kind of worms open up. Because they're not tested. They're not 20, 30 years, Because security, you need knowledge over the years. Like the COVID vaccine. Many of you took COVID vaccine, correct or not? Is it good, bad? Arguable, correct or not? I would say I got personal experience after taking COVID vaccine. My body get different complications. There's people have also affected through vaccine. Of course, we got no choice because that vaccine, in order to be tested, we need 7 years, correct or not? 2 years, what you can do? So take chance. Similar goes to the scenario, similar scenario. So when it comes to services, so you got security framework like service-based architecture, unified access authentication, internet working. So all this architecture enable new architectures, enhancement, new security features. Later, Prof. Suresh will talk about IPv6 enhanced. Now we are IPv6 basic, can't able to support enhanced because now 5G works with SRv6 segment routing. Now remember SRv6, we talk about that. So the challenges are big. A lot of things need to be addressed. So I'm just giving you a tip of iceberg only, right? The security challenge, not dive into really 5G. So today 5G as well IPv6 is interwoven. So 5G, IPv6 drive 5G because we run out of IP, we have to go. We know how to implement IPv6 over 5G network. You must know how to do subnetting. Now again, there's other challenges are there. Because IPv6 is a very talkative protocol. And 5G, we are promoting, massive communication. Remember, we need IoT. For IoT, run on batteries. So if you are using a protocol that takes up, very talkative protocol, it takes up energy, how are you going to run on IoT devices? So we need to implement 6LoWPAN, some other technologies available. So there's a lot of things that working good. Of course, 5G, we are trying to up and running to solve the basic problem. But the other problems are there, IoT, and because this is what really brings in. So come to security. Of course, now he's trying to fix the network issues, not even touching on 5G security. So security is something that we need to address it in a bigger picture. You understand now? So this is why we are trying to share here in this session a lot of challenges that are available. Of course, to give you exposure. I mean, some of you already implemented, some of you might not have been implemented, some of you on the way. Of course, going IPv6, definitely way forward. There's no return back. IPv4, as I mentioned earlier in the morning, IPv4 will not stop. Will be a dawn technology by 2025. US not supporting that. China by 2030 make a firm decision. No more going to support IPv4 at all. So we have to go to IPv6. So when you go to IPv6, we have to embrace the IPv6 enhanced and other technology to enable 5G networks runs to support the application. So this is what we are talking about. Okay. So with that, I'll just complete my presentation. Are you ready? Yeah. Okay. There's any question? Yeah. Yeah.
Could you please give us some takeaway, right? What are the advantages of using the 5G network, right? What are the key takeaway from the 5G, or what are the some obstacles, right? Apart from the security challenges, what are the other benefit using the 5G network?
Good
Including
question.
IPv6 as well. You are also mentioning some of the organizations, they are already declared to use only IPv6.
Yeah,
that is true. But have you ever get an experience about these challenges using the IPv6, especially in the dual stack? Like in the service providers network, there are so many challenges even in the gateway, right? There are so many bomb traffic is generating from the IPv6 for the ND process, right? Have you ever identify the that challenges and the mitigations techniques so that the APAC community also like take advantage from the researchers like you, so that even in the service providers can get update from the researchers people, right? So that it will be easy for us as well. Thank you very much.
Thank you, Ram. Thank you for it's a good questions. Of course, 5G brings a lot of advantages. I think I covered already. We're talking about latency, low latency, high bandwidth. These are the basic Why want to go 5G? High speed. People want performance and low latency, better for security, all right? Reduce latency and all this. Good points. You can increase number of devices in cell. And a lot of new benefits are there, right? Like what you rightly said, 5G is still, even though it's been introduced quite some time back, it's still the challenges are there because there's not many implementation. Now, we are now talking about sub-6, which is up to 1 gigabits. Now, even not gone to 5G core. Because many countries, as I know, they haven't implemented 5G core. They're still running 4.5G, we call it. Because even though 5G, but it's actually enhanced 5G, 4G. So the challenges are already there. Is there, especially you're saying security part. Of course, best practices are still working on. Like this morning, we talk about BGP. Of course, BGP security issues not related to, because you're not, I think he wasn't there. You can see what Hafiz has to highlight, Dr. Hafiz. He mentioned about BGP. Now BGP got IPKI, and now we're talking about BGP-SAC. So it's immaterial with IPv4, IPv6. So security issues, challenges are there. What is the best practice? Of course, some people say use RPKI. Fine, that's a good thing. But use 5G SAC, BGP SAC, security. BGP SAC, open source, still in research discussion. You understand now? So same goes to, there are a lot of ongoing, I can't answer 100%. But over time, things are happening, like I was sharing the 5G security, new problems are created, and we have to address the problem. If you remember just now, Prof. Maya and I mentioned, when first I was exposed to IPv6, I heard about SAVI and SAVA. Have you heard about that? This from basically from Tsinghua University, SAVI and SAVA. Chun, Prof. Chun. Okay, so SAVI and SAVA, they were, because that time the Chinese were rolling on IPv6, so they saw the challenges and they were introduced that of RFCs. Okay, SAVA and SAVI. I mean, so this is the thing. So as we go, maybe the RFCs need to be redefined. Okay, so challenges are there, a lot of challenges. Of course, at this present moment, at this short time, because hopefully the next year, next meeting, we have a much bigger event, working group. I could able to share more things, but a lot of work has been done in the security area, especially, my focus is on 5G security as well as IPv6 security. So security is my interest area. Hopefully, maybe some of you can come through my LinkedIn and get to know, maybe I'll share some information. Hope to share more things because there's a lot of things they need to be discussed. I cannot get everything to be explained in this session, but hope to give you more. Okay. So because of time, I think we will finish here. The question, you can talk later. We'll try to finish by 12:30 so that you can guys go for lunch. All right. So we have Prof here. Okay, now I think, okay, so you can start talking. Now I try to introduce Prof, then I will share the slides. Okay, so just to give you an idea, Prof Suresh, he is with currently with the Malaysia University of Science and Technology, and he used to be the one of the pioneers in Malaysia in IPv6. So currently, he was a former APAN chair as well. Okay, he was a chair of the APAN, and he has done a lot of work in IPv6. Currently, is also administrative chair for the IPv6 Global Forum Education Program. Right, so he has a lot of experience in IPv6. He's much pioneer, kind of my guru also. When I started IPv6, I will learn IPv6 from him a lot. So he will share a little bit on this white paper and as well IPv6 enhanced. Okay. You can.
The organization is called the Asia Pacific IPv6 Council. The council is free for people to join. The main members or the voting members of the council will be governments. The aim of this council is to work with governments to help them push IPv6 into their country, to make it more aware. So right now, we all researchers, for us, IPv6 is not a problem. We understand it. We are looking at IPv6, already the advanced versions of IPv6. You guys are all working on security for IPv6. Some of you are working on new routing protocols. Some of you are working on SDN for IPv6. So IPv6 as a pure protocol is not exciting anymore for you all. You're working on advanced versions of IPv6. And you should. IPv6 is more than 20, 25 years old, right? So I remember in 2000 when we actually launched a full-scale deployment of IPv6. It's now 2024, 24 years later. So for you all, the excitement will be research, adding new technologies. But we must also understand that some of the developing countries in the Asia-Pacific region do not have connectivity. I was just talking to an old friend of mine, Akira Kato, who was outside. Now he is working on IPv6 DNS. And we are talking of Laos, where they have a shortage of IPv4 and practically no implementation of IPv6. Anyone from Laos here? No. So you see, countries like that need our assistance. And this is where the Asia Pacific IPv6 Council will go in to help them. So we need to get, so while a lot of us are already, as I said, connectivity is not an issue, we are talking of research. There is still countries where connectivity is an issue. And you must understand there's no more IPv4 addresses to give them. So we have to teach them to deploy on IPv6. So this is what this council is set up for. I will present a little bit on that. I wanted to also talk a little bit on IPv6 over 5G. I will address that as well a little bit, but not with slides. So when did we launch? We started this project in August 2023. What are we? We are a non-profit organization, basically established to collaborate between government, industry, and academia to develop a strategic roadmap that outlines the key initiatives and milestones for IPv6 adoption into the region, real IPv6 adoption, right? The vision is basically to transform towards a new internet based on IPv6, closely working with governments and regulators, service providers, and other relevant stakeholders to foster a sustainable and interconnected digital ecosystem across the Asia-Pacific region. These are the council members. So initial members, Latif, who is our IPv6 forum chair, myself, and then we have Mr. Krishna from India, and now Australia, Mr. Robin Lee from China, Mr. Will Liu from China, and Ms. Wali from India. The goals are to promote IPv6 awareness and education, to drive IPv6 policy making and regulatory framework creation in Asia-Pacific region, to facilitate IPv6 test and deployment infrastructure, to monitor and evaluate progress of IPv6 adoption, to engage with international forums, to foster global collaboration and identification of member states, key stakeholders, current adoption rates, challenges, and strategies. Deliverables for 2024. So we have some specific targets that we have identified. So we identified goals, targets with the team. The first thing was, of course, the establishment of the organization. It is not so easy to establish a non-governmental organization, not for profit, which covers a region. You can do it for one country, but when you say you want to establish something that covers like APAN, when we established APAN, we also had a lot of challenges. Now, identifying member states and establishing correspondence with them, we have started doing that. To define the strategic roadmap, we have already started with that. To define the IPv6 capacity building, we have done that as well, awareness, training, and testing. So all of this, we have started building parts of it. Participations right now in international conferences, workshops, and forums. We have done the IPv6 Enhanced and 5G Global Conference in Malaysia. That's where we launched it. Then the Cyber Oz Conference in Sydney, Australia. IEEE Conference in Bali, Indonesia. The APAN56, that's today in Bangkok, Thailand. And the Mobile World Congress in Spain. So we've identified this 4 out of the 5, we've already done it. Technical contributions to IPv6 Enhanced Council for the APAC region. We also want to have SRv6 or segment route version 6 deployment guidelines for the APAC region. Segment routing is a very nice, interesting research area. And it allows you to, if you look at deeper into it, it allows you to embed code, not 8. In IPv6, IPv6 allows you to embed code in the header extensions. I don't know how many of you have explored in it. Have you? You have? Have any of you explored the coding part of the IPv6 extension header? Think, I can now write pieces of code and put it into packets. Think how that will revolutionize the way networks work and the way traffic flows. Code inside packets. Every router that receives it will decode the code. Also along that line, if you think of the security challenges that are going to happen when that happens. Right? So those of you in security like Dr. Nawa and his team, this is a very important area they have to look at, because if I can write code, hi Liana, if I can write code and code goes in to that router and the router decodes, if I write things to manipulate the router wrongly, who's going to correct that? Who's going to be the watchdog on that? Food for thought. Council's first initiative is to establish and publish a white paper titled the IPv6 Evolution Roadmap and Implementation Guide. This paper has already been published. It should be on the website. I have to check with the secretary to see if they have it there. Second is to collaborate with the World Broadband Association, WBBA, to increase awareness and cultivate best practices. So this one, probably we will sign the MOU with them during the Mobile World Congress in Spain. Right. So there is, if you look at IPv6 today, the drive, if you look at the internet today, 50% of the traffic is now IPv6. Do you all know that? That means 1 out of every 2 packets is IPv6. My next question for you all, who generates those IPv6 packets? 50% IPv6, right? Where are those packets coming from? Mostly from? What is it? No. When I'm talking, maybe I should be more specific to my question. What kind of devices are they coming from? Home networks, work networks, mobile networks. So wait. So who? Mobile. 90% of this traffic comes from mobile networks. And you know why? ISPs. The ISPs are doing such a good job in pushing IPv6 that all your mobile connectivity comes with IPv6. So when you use your mobile to send let's say send a simple WhatsApp message, it's moving in IPv6. That becomes part of that 50%. Your home networks, your enterprise networks, believe it or not, most of it is still IPv4. Some of it, they have IPv6, some. A lot of it is still IPv4 because enterprise means somebody needs to go into that organization. They have a router, put in IPv6, implement IPv6 into that organization. 95% people don't do it yet. But the world is being driven by mobile, right? Remember what Dr. Nawaz said, right? A lot of malware now sits. If I'm developing malware, what platform would I develop it on? What is the fastest growing platform today? Shankar, what is the fastest growing platform today? Android, that's operating system. Platform, what does Android sit on? Mobile. If I'm developing something today, if I'm developing malware, I'll develop it for the mobile. Everyone has a mobile. Not everyone has a PC. My maid has a mobile. She doesn't have a PC. My maid's children have a mobile. They all don't have PCs. Right? Everyone think. Everyone you know has a mobile. If they don't have a mobile, you're like, what's wrong with you? My boss didn't have a mobile. We all looked at him and said, what's wrong with him? Right? He didn't believe in mobiles. Otherwise, everybody has a mobile. So this is their target. Everyone's target. Any application you're doing now, mobile first, then PC. So even the web, the browsers have to ensure that they are mobile compatible. Then only they work with the PC. Anyone in this room doesn't have a mobile phone. Everybody has. How many of you have two or more? Shankar has two. There you go. Oh, see, two. Amazing. So the mobile has taken over the world. So whenever you're looking at IPv6 traffic, you're looking at really what's being generated by the mobiles. But the enterprises are moving. They're moving fast. Moving fast. So let us give credit. The ISPs have done a good job. And who can tell me why the ISPs are all moving to IPv6? It's not because they love you or not because they love me. Why are they moving to IPv6? Why do ISPs do anything? What is their main objective? For business, yes. And what is tied to business? He is technical. This guy looks at everything technically, which is good. You got to look at it from the business viewpoint. When you ask the CEO, you tell him that, he says one question: am I going to save money or spend more money? With IPv6, you save money, right? You save money. I don't need a net. My security devices come down. The net part is already a big thing. But you know, one more thing that I have. I have a storage of IPv4 addresses which I can now sell off to the people who want to buy. So the people don't realize it's like a stock market, right? So V4 is right now peaking. I think they're about $50 an address. If you have any, sell it off. Because within the next 3 years, it'll go down. Like the crypto went down, it'll go down to about 1 cent an address. Because everyone realizes I have an IPv6 alternative, which costs almost nothing, free. And then I have a V4, which I have to pay 54 for. Doesn't make sense, does it? You got old technology. It's like saying, okay, I'll sell you an old petrol car for 5,000, but I can also give you a new electric vehicle for $1. Which one would you take, the 5,000 or the $1? New one, $1, right? So when you look at that, you're like, then why aren't ISPs changing? Why is this still slow? You know, people are comfortable. I still drive a petrol car, right? Why don't I change? Comfortable, lazy. When the car breaks down and it cannot be repaired, I will get a new electric car. You see, it's like mobile phones. Nava and I we have this discussion with DNB, our national 5G rollout company, right? And the big thing in Malaysia is our outreach on 5G is very good. We've rolled out 5G, almost 80-90% of the populated targeted areas of Malaysia is covered by 5G. But the usage of 5G is very low. Who can tell me why? So this was a question a student in my class, one of my lectures I give, and the student in the lecture theater, there was about 60 students. One of them raised their hands and said, sir, why is, if 5G is so great, why is the traffic or utilization of 5G so low? So then my question to them is, how many people in this classroom have subscribed to 5G? One student raised his hand. And I asked him why. He said, because my phone died last month. And when I bought the new phone, I bought it with 5G. Same thing. Same thing like IPv4, 5G. Reason, how many of you have got 5G here? Even I don't have, right? So few of you. Why did you switch to 5G? Unless you're very techy, the question would be a normal question. But why did you go? You got a new phone, right? You got a new phone. I spent money buying this Nokia P30 last Android series before they stopped Android. I spent almost slightly less than 1,000 US on it. I'm not going to change the phone till it dies, right? One of the student goes usually after we drop it in the toilet that we change the phone. Yeah. So again, the reason is 5G hasn't caught on in Malaysia, not because people don't like it, not because it's expensive. It's the same cost. The ISP is not charging you more in Malaysia. It's because the guys with the mobile phone don't want to change their phones yet. Right? So, but give it 2 or 3 more years when all their phones die or they give their phones to the children, they get a new phone, it will have 5G. My next phone will definitely have 5G that I can get. I want it, I just don't like my old phone. So I just haven't migrated. So you all understand now. Concept of migration is usually people are very comfortable with technology. So the old ISPs, the ones you see that are moving IPv6, IPv4, are the old ISPs. They don't want to go and change. But all the new ISPs, how many of you are from India? Nobody from India. So India has this new ISP called Geo. They came into the picture. India's IPv6 traffic, we were all working with the Indian government trying to get them to move to IPv6. Oh my God. It's like, government's like, yeah, we'll do it. But the people in the industry just, it was like 0.1 or 2, less than 1%. Then this company called Geo decided to launch a new ISP network. Overnight, India went from 1% to 50% IPv6 traffic. Overnight. You know why? The entire Geo network, they came out with almost free mobile phones for people. So a lot of people subscribed. And all those phones ran IPv6 only. The engineers were smart to keep costs low. They built a whole new network purely on IPv6. So cost low. Immediately, India appeared on the IPv6 world map as the number, I think it was like number 6 or number 5 IPv6 traffic country. From nothing, from nowhere in the map, suddenly, one ISP. Okay. That's the difference. Okay. I think my presentation is pretty much done. Slide doesn't want to work either. Noah kind of gave up on me. Can you manually just click the next slide? Okay. So this is during our launching. Picture from the launching. Next slide. I think that's it. That's the last slide. That's the last slide. If you all have any questions, IPv6, 5G. And by the way, IPv6, if you're implementing 5G, you have to implement IPv6. Not because I love IPv6, you have no choice. 5G is massive connectivity, massive end-to-end connectivity. Only one choice, IPv6. If you want to do massive end-to-end connectivity with IPv4, you don't have enough addresses or you have to NAT, both of which really is not encouraged under 5G. Right? So those of you young guys here who are now going to advise your governments or advise your ISPs or your organizations, if you're implementing 5G, it's IPv6. And if your organization is not using IPv6 yet, do the assessment, take a look at how to implement IPv6 into your organizations. If you have any questions, you can always ask the APAC-V6 Council. We have people who will help you all for free, who will guide you all, get you all moving on the IPv6 path. Any questions from anyone? Yes. Thank you.
Right. You also mentioned IPv6 adoption globally is rapidly increased, right? That is true, right? And most of the mobile device are more like a and more like a user friendly in IPv6, right? In your research, right? What are the roadblock for enterprise? They are not moving to IPv6.
So, okay. So again, the roadblock is they are happy using what they have. So as a consumer, you use what you have. As a consumer, you don't, honestly, you don't know whether your mobile is IPv4 or IPv6, as long as it works, right? So just like ISPs and people, if the enterprise already had something and it's working, chances are he won't switch. He's happy. It's the new guys. Okay, I've got a new network. I need to set up a new network. V4, huh? So much. How about V6? Oh, free. Okay, I switch to V6. Right? So that's the simple reason, right? I switch to V6. So chances are, in order to connect to V4, they still need maybe one IPv4 address and then the rest is IPv6, or the ISP itself will do a translation for them. So really, you could be a pure IPv4 network. I'm sorry, a pure IPv6 network if you're new, right? The old guys, the other thing is, what did you study in school? When you were in university, did someone teach you IPv6? They did. Which university you're from? So none of my lecturers even knew what IPv6 was, right? None. How many of you actually studied IPv6 in school other than him? He's the only one I know. Shankar, of course, I taught him, but huh? You had 4 and 6 both? Also a very good university. Which university? Australia. Anyone else? So all of you, V4 only. Right? When you go to university, you learn networks, they teach you IPv4. Right? Why? You ask the lecturer, he said, well, nobody taught me IPv6, so I can't teach IPv6. The other thing is capacity building. So another answer to your question, why haven't a lot of people switched to IPv6? They don't have knowledge in it yet. So I learned IPv4, so I want to implement IPv4 is their answer. Right? I know it. I'm comfortable in IPv4. You want me to implement something new, but I don't know it. And I don't need it because it's working. That's the if he needs it, he'll learn it. But he says, I don't need it yet, because it's sort of working. But the new guy, new network, since you have no more V6, V4 addresses, so it's expensive, the boss will say, I wanted V6. So then he has to learn. Right? So he'll attend the course. Either he'll attend the course online, he will go to a certified course for engineers, IPv6 engineers. Somewhere he will learn. He has to learn. Then he will say, hey, this is better technology. Actually, it's not that hard to implement V6. Simple, straightforward V6 you can implement. And for those of you who didn't know, IETF has stopped support, has discussed it and has stopped support for IPv4. So any new IPv4 protocol that's coming out, they don't do thorough security, how do you say, work on it anymore. You have to do. If you have a V4 thing that you're coming out, you have to go do all the work yourself. Whereas if it's IPv6 based, they will do the normal security stuff on it. Right? So world has changed. Some people are slow in changing, still changing, right? But it's inevitable. Change is inevitable. I can tell you now, 10 years from now, you'll almost see no more IPv4 networks. Anyone here wants to take a bet? I'll take a bet with you. 10 years from now. The last time when we talked about, almost in 2015, when I was talking about IPv6, I think the global IPv6 traffic was only 5% of all. Today it's 50%. And you look at the map, it's like they're going this way, and it's going to go this way, right? So the uptake is very fast, very, very fast. Everyone's just switching. AWS just announced. I don't know if you all are familiar. AWS says if you are going to use IPv4 on the server, we're going to charge you extra. If you're going to use IPv6 on their server, it's free, no charge. You're going to use IPv4, we charge you extra per second. AWS charges by the second. So every second you use an IPv4 address on their server, they charge you. Yeah. So they are telling you switch. They say switch. Why aren't you switching? Switch. So it's not just us. As I said, the change is happening and it's happening very fast. If you don't change, you're going to get left behind. If your country doesn't change, they're going to get left behind. Your organization doesn't change, they're going to get left behind. Any other questions? Anyone?
Yeah, adding the another question as well, right? We are working with IPv6 almost like from 2007 or 8.
Okay.
I think we are the first ISP in Nepal who deploy IPv6.
Very
like,
good.
It's a dual stack.
Very good.
And at that time, I think that was in 2007 or 8, we started the APAN, right? And now most of the traffic in IPv6.
Very good.
Right?
Okay.
Almost like a more than majority of the ISP, there's more than 60% traffic in IPv6 and the few traffic in IPv4. And after deploying IPv6, the performance with the end user is better. No need a NAT, right? The NAT is like a
I should record you and put you on our website. So we are recording. Yeah, okay.
Indeed. My another question is like in terms of regulatory body, the IPv6 APAC Council also working with the many regulatory body as well. Right? We also give some feedback to our regulatory body. Right? What are the things we have to suggest for the regulatory body to adapt IPv6 more in the, as soon as possible, right?
Yeah.
One of the challenges which we are faced, especially in the enterprise customers, is like there are so many applications developed in IPv4, and the developer is more familiar in IPv4. That is a legacy.
Right? Yes.
And it took a time to change that software to IPv6.
Yes.
Because of that, the enterprise company cannot move to IPv4 to IPv6. In the APAC IPv6 Council's study, when will be the Asia will move completely V6? It's not a dual stack, it's like a native V6.
Yeah, very good question. How many of you are familiar with banking systems? Right? You are, right? So you come from industry and strongly connecting industries. So you will understand what I'm going to say better. The old banks, till some of them till today, still have AS400s. How many of you know what an AS400 is? I know, you know, but anyone else? AS400s was when my father was working. You had AS400s. That's 30 years ago. 30 years ago, AS4, big monster machines. You know, you put one here, the CPU is as powerful as my mobile. That's all. But it's huge. It has huge data storage and they have software that works. So the bank doesn't want to change. You know, the parts for that machine is almost difficult, impossible to get, but they'll source. They'll say, okay, go buy it, come and replace it. They don't want to change. Why? It's working. So it was created when I was 18, 19 years old, but they still want to keep it today. Until what's going to happen eventually, the guy is going to say, look, it's going to die. Then they are going to hire people to start migrating their software. They're going to look for something new. Because a migration process for an organization like a bank, it's huge. Lots of money has to be spent. Money is just one thing. The timelines, And then the IT guy, the moment you tell him this, he'll go home, he'll look for another job. He will run away because the migration work is tremendous. You're switching everything in a bank. And banks, security is an issue. If I'm switching data from one to another, it's an issue. So they all get very cautious, very, very cautious. Sort of answer your question. Right? You see that caution to move, right, from a legacy system to a new system. But the moment that move is done, their job is so smooth, so easy, parts are easy, software upgrades. People can't even write code in AS400. How many people do you know that can write COBOL? How many of you have heard of COBOL? Like 5 of you have heard of COBOL. Those machines use COBOL. So, you can't even find people to program it, but they need to keep it alive because they are already in the phase of migrating. Right? Most banks are already migrating today. See, so you can't, how would you say, blame them for that. But any such migration takes a long time. And government say, okay, puts a budget, tell the IT guy, okay, you do it. The IT guy will hire a company. He'll say, IBM, okay, how much to come, Machiniaga, how much to come and do? And IBM or, one of the big guys, HP will come and do the migration work for them. That's governments, right? But banks are very thrifty. Banks and organizations look at things differently.
Okay. I think we have run out of time. I think another speaker is the last one. Okay. Thank you, Prof. Thanks for the insight. Thanks for coming. All right. So thank you. Now, the last speaker for today, he is coming all the way from Somalia. Okay. Ibrahim, are you there? Ibrahim?
Yes.
Yeah, you can start share your slide. Okay. Ibrahim actually is from NCA. From Somalia. So recently I've done some work for NCA to provide them IPv6 strategy for that country. So this is part of the ITU project. So I work with Somalia, and basically he's going to share what are the strategies that required to move IPv6. Okay, the mic is yours, Ibrahim. You can continue presenting.
Thank you very much, Dr. Neva, and thank you to the participants, both those who are at the venue and those who are joining remotely. Can everybody see my slide?
Yeah. Could you go on the full presentation? Go on the full presentation.
All right.
Full. Is it possible to do that full? You go down there's a button down there.
Yes.
Down.
You cannot see this.
Can you go down? There, that's the one. Okay, good. That's good. Okay.
All right. Okay. So I think it is already good. It is afternoon there in Bangkok. So and it is almost lunchtime. So I'll quickly go through my presentation and will not take you long from your lunch. With you, the IPv6 migration strategy for Somalia. This is the work Dr. Neva and I and other members have contributed to develop this strategy for the country. Okay. All right, we will go through a brief background of Somalia's digital status and to see how Somalia is placed digitally. And then we will look at the deployment status of both IPv4 and IPv6. And then we look at the some benchmarking of other countries who have who share similar context with Somalia, and how they have managed to implement the IPv6 migration strategy. We will look at the transition strategy developed for the country and the phases it has. And finally, we will conclude the presentation. All right. This is just a snapshot of Somalia's digital adoption as of last year. This is a nation of around 18 million people. And around half of that people live in urban and big cities. And in terms of the technology adoption, there are around 45% of the people who use cellular mobile connections. Of course, these are referring to the smart mobile phones who are able to use like 3G, 4G technologies. In terms of the internet penetration, now compared to the total population, the penetration rate of the country is around 10%, with almost 11 people of that population use they are active social media users. So here you can see the gap that is already there in last year. This gap tells you that the internet penetration rate required by the target set by the government is far more less than the current state. And here, this graph shows the growth of the internet users over time since the last 10 years, from January 2013 to January 2023. So from 10 years ago, the internet users were only 200,000 people. Now they are about 2 million people who use the internet in the country. And you can also see the year-of-year change over that decade. All right. In terms of the IPv4 public address deployment status, Somalia is on the 178th place globally. So that is 0.001% of the whole IPv4 addresses as of July 2023. So Somalia need to have more public IPv4 addresses to achieve the target of the penetration rate set by the government of 25% by 2025. So since IPv4 already exhausted globally, Afrinic is unable to allocate any more IPv4 addresses. So the current state and the target, there is a big gap between the current deployment state and the target set by the government. So and here the IPv4 addresses are already exhausted. So there is no the Afrinic is not able to allocate the required number of IPv4 addresses. If we look at the deployment status of the version 6, Somalia is on the 106th place globally. That is 0.003% of the whole IPv6 addresses. That's also as of July last year. So with reference to the above statistics, the Federal Republic of Somalia need to have more IPv6 global unicast address in order to achieve the additional 21.3% penetration rate by the 2025. So this target was a part of the ICT policy and strategy developed from 2019 to 2024-25. So that target, that strategy states that Somalia need to reach 25% penetration rate by 2025. Here, we have done some benchmarking of the IPv6 implementation with Saudi Arabia and Egypt. Those are countries with similar context and in the region. So you can see that we have looked at the different angles. We have looked at the country population. We have looked at internet users, internet penetration rate, the allocation of IPv4 addresses, IPv6 addresses, the total addresses used so far, both version 4 and 6, and users per IP addresses. So the difference is that in Somalia, the IPv6 task force have not been established yet. There are plans that they will be established early this year. If you look at other countries like Saudi Arabia, the task force has been established in 2008, while in Egypt, the task force has been established in 2004. So, all right. So in order to for Somalia to migrate to IPv6, this strategy has to be followed. The vision is to implement the IPv6 for the continuity of the internet and support the latest technologies, such as the 5G, Internet of Things in the country. The mission is to achieve the 25% internet penetration rate. And we also need to, in order to implement this strategy, we need the formation of an IPv6 task force. This task force will guide the implementation and monitoring of the IPv6 strategy in the Federal Republic of Somalia. We also need to develop regulations, guidelines, and technical specifications with the support of the local ICT stakeholders in order to support the transition of IPv6 in the country. There also should be some KPI monitoring to monitor the implementation and progress of the adoption of the version 6 protocol of the internet. And finally, there is a need to participate in the regional and international events to share knowledge and experiences and exchange ideas and strategies to address the challenges faced while implementing the strategies. Now, the strategy being developed for Somalia has 3 phases. Each phase will last 12 months, that is a year. The first phase is preparing for the transition. The second phase is the implementation of the dual stack operation. And the last phase is to monitor and make changes to the strategy. So in the first phase, we will look at 6 different angles. First of all, we have to establish a specialized training center to prepare the local force with IPv6 knowledge. And then we have to request additional IP address allocation for IPv4 and IPv6 to support current and future needs. We have to also conduct a series of workshops and IPv6 summit locally to promote IPv6 technology. We have to also ensure effective participation in the local, regional, and global IPv6 workshops, conferences, and other related activities. There is also a need to establish test labs to test the hardware and software before going into real production environment. And finally, there should be a conformance policy that is in line with the international standard and that establishes the conformance of the test lab locally to test before allowing the product and services to be distributed locally. So here in the regulator, we have a unit that is in charge of the type approval of the hardware and of the devices. So the plan is that it has to be included in the future needs. The type approval requirement has to conform with that policy and ensure that all the future technology devices should support the IPv6 technologies. In the phase 2 of the implementation of the dual stack operation, this strategy, the dual stack strategy, has to be discussed by the stakeholders, and then each stakeholder need to implement before starting the dual stack infrastructure. And this enables the operation of the infrastructure networks of the ISPs, exchange points, top-level domain of the country code, and other relevant stakeholders. So those stakeholders need to enable their infrastructure to work both in dual stack mode. And we have to also prepare the dynamic host configuration protocol servers, DNS, and webs to support the dual stack operations. And finally, it should enable the commercial internet service that is based on IPv6 for consumers. Okay. All right. In the last phase, that is basically to monitor and make changes to the strategy. So the government has to ensure that the target has been achieved and provide support to local stakeholders to use the latest technologies such as 5G and IoT. The government has to also ensure the targeted network services and applications are supporting the version 6 of the protocol. And then it has to also ensure the penetration rate is achieved and make any changes that is required if the above target is has not been met. This is just a timeline that has been proposed. This timeline starts from 2023 up to 2026. However, change management is absolutely necessary among the local ICT stakeholders. So they will be supportive of the government vision and mission over time. So the introduction of new technology could change the strategy over time, and local stakeholders should be prepared to accept this change. So as you can see from these recommended milestones and timelines, we have not been able to start and establish the task force in time. This would be this would be shifted to this year, and from this year, each phase should take 1 year from its starting point. In conclusion, I would say that with the exponential growth of the internet users in the Federal Republic of Somalia, the version 4 of the internet protocol is unable to support this exponential growth because of the limited addresses within the rear in the region. So immediate actions are required to implement the version 6 in order to support this demand. This strategy would assist the Federal Republic of Somalia in implementing the version 6 of the protocol in stages to achieve the internet penetration target of 20% by 2025. Thank you very much for your attention. And I would like to acknowledge one more time Dr. Neva for having for supporting the development of this strategy and for giving me this opportunity to present this with you. Thank you very much. Back to you.
Thank you, Ibrahim. Okay, any question to Ibrahim? I think we're almost near to lunch. I think all of you are on the way. Okay, good job, Ibrahim. I think Somalia is a typical example, which is developing nation that moved to IPv6. They already started well with ITU supported them to do the strategy. Now they are going on the next level. So I think the whole African region is, things are happening. Honestly speaking, Afrinic, I mean, talking about Afrinic, Afrinic is one of our ATP under the IPv6 forum, and they're very aggressive moving forward. So things are happening in the way. Then we can see 2025, one more year, US going to stop working IPv4. 2030, China already announced no more support for IPv4, like Prof. said. So let's don't talk about IPv4. Don't tangle with that. Let's move on to IPv6. And we have to move. There's no more turning back. So if you need any more discussion, or I think you can contact me. The slides all will be on the website. You can get the slide. If you guys want to do any work in research in 5G, IPv6, I think both myself, Prof. Suresh, even Dr. Shankar is here. We were very pioneers in this. We've been doing training globally, doing capacity building around the world. And I just met Prof. Sinchai from Thailand just now. He's still around. I think he's still not retired. So very much so. So you can keep in touch with us. Thank you for joining us today. And we hope to see you the next APAN meeting. Thank you very much. Thank you, Ibrahim.